If you look up the board with me, together today we're going to learn about salts, Ka, Kb, and buffers. You're going to understand what a salt is and how to determine if it's acidic, basic, or neutral, what a buffer is, and their uses. You're going to understand how to be able to use Ka and Kb to determine the strength of acids and bases, and you're going to be able to understand how to make buffers. You still need to be working on your Learn Smarts, Chapter 9, and homework A and S. Next time, lab. Everybody listening? Next time, lab. Part D, you need to bring a juice or a pop. 30 milliliters. Okay? And we're finishing Part B4. I will not be here on Monday, the 11th. It will be a work day. On Thursday next time, I'll be giving you your review. So you can work through it on next Monday. You can work through getting your homework, your whatever's done. Okay? On Wednesday when I come back will be the review where I go over it. I'll also make sure I put the review up on Monday night so you can go back through and see what you've missed. If you don't understand it, we can answer questions. Also, the special review March 13th. Okay? March 13th. Make sure you plan on getting done with both D and B4. If you have not, you don't think you have enough time, make sure you're coming in tutorials. Okay? Wednesday and Friday. So you're up and going with what needs to be done. Because we'll be taking that lab down. I'm going to have my aides take it down on Thursday after this period or Friday, depending on. Okay? So make sure you're ready to go on that. They will not be up next week at all. So I'm taking all down for next week so we can clean up and make sure everything's nice and tidy. That was interesting. Okay. So, don't forget about Part A on your lab. Please remember to bring me this back. And just set it up here on my desk when you bring it back, when you're done with it. Okay? All right, going forward. Let's talk a little bit. A hydrate, salts can have a hydrate. How many have heard of Epsom salts? What are they used for? Okay, it's actually just magnesium sulfate. But the magnesium sulfate is a heptahydrate, meaning it has 7 waters attached to that salt, even though it's in crystalline form. It does have salt associated with it in its crystalline form. So because in its crystalline form, it also has the ions. Water of hydration are water molecules that are attached to the salt. So if it's a hydrate, it will have water of hydration. An equivalent of a salt is how much, the amount that will produce 1 mole of positive electrons when dissolved and dissociated. So we're not going to talk a lot about equivalents. There's a part in your notes I'll actually be having you cut out because she will not test you on equivalents, so we're not going to go into it. Okay? All right, so reactions that yield salts. You need to make sure you stay up with me today. We're going to go fast so that the harder parts that I've noticed, we can slow down. You need to know what happens when these happen. Okay? So when an acid reacts with a metal, that's like magnesium in hydrochloric acid. That is going to give you hydrogen gas and salt. If you react an acid with a metal oxide, that would be like reacting sulfuric acid with magnesium oxide. You're going to end up with a salt and water. If you add acid with a metal hydroxide, basically acid and base, right? You're going to get water and salt again. If you add acid with a metal carbonate, this would be like adding hydrochloric acid with sodium carbonate. You're going to end up with salt, water, and carbon dioxide. These last two we use a lot in baking. If you have an acid and a metal bicarbonate, like sodium bicarbonate, baking soda, you end up with a salt, water, and carbon dioxide. So we need to be able to predict what's going to happen. We also need to be able to given a salt, be able to work backwards and tell what that metal, whatever, oxide, hydroxide, carbonate, bicarbonate would be, and what the acid would be that we'd have to put together to make that salt. We're going to go into that a little bit more on the next slide. Are we okay to go forward? Okay. So when we talk about acidity and basicity of salts, or alkalinity. Salts can be acid, base, or neutral. And when they're dissolved in water, they can make the solution a little bit acidic, a little bit basic, or a little bit neutral. For a salt, you're going to be worried about the positive side and the negative side of the salt. The M part, or the positive side, comes from the base. The A, or the negative part, comes from the acid. Now remember, to make an acid, all you're going to have to do is add hydrogen to that negative part of the salt. To make a base, a simple base, you're going to just take and add OH to the positive side of the base. Okay? Is everybody okay with that? Strike two. Pay attention, please. You're going to hate life if you don't know this, because this is a lot of what's on the test. Okay, the acidity and basicity of salt. So if I had sodium chloride, I would separate it, and I would say that the Na plus would go with OH minus, making NaOH, and this is a strong base. The Cl minus would separate, combine with the hydrogen, making HCl. That's a strong acid. And I'd say, okay, I've got a strong acid, I've got a strong base. They will neutralize each other, and my pH will be 7, and I'll be neutral. So I need to know this. We're going to do another one here in just a minute. And then I'm going to have you guys do some and put them up on the board. So make sure you're understanding what I'm doing. Okay? So I can also take something like sodium bicarbonate, separate it. Na is going to go with the OH. It's going to be a strong base. HCl3 is a negative ion. I'm going to put another hydrogen with it. It becomes a weak acid. I've got a strong base and I've got a weak acid. Because of that, the strong base sort of takes over, and it becomes a basic solution, or pH above 7. Make sure you're getting the notes down so you know what to do coming up. So I'm just taking you through step by step of what needs to happen when you're looking at a salt. Okay, going on to the next one. Ammonium chloride. Split it to its ions. NH4 goes with OH, making a weak, or forming a weak base, or giving up the H. So you could do it either way. You could say that this became, add it to the OH, and it becomes NH4OH. That's a weak base too. Okay? The chlorine will combine with the hydrogen, making chloric acid. Ammonium hydroxide, or ammonia, is a weak base. HCl is a strong acid. So because of that, the strong acid takes over. Strong acid is going to be below 7. Okay? So you've got to be able to split them yourself. Make sure you add to the positive, the negative OH. Add to the negative, the positive hydrogen. Okay, you ready to try it on your own? Guess we'll find out. Okay, I'm going to sign out. All right, let's see. Jacob, you've got A. Justin, you've got B. Tiani, you've got C. Tyson, you've got D. Jaden, you've got E. Carly, you've got F. You don't have anything, Caleb, this time. Okay, if you need help, let me know. All the rest of you still should be doing all of these and seeing if you can get them right. Also, once you get it figured out, go ahead and put it on the board. Okay, split it to its ions. What ions do you have?
Cu and NO3.
Right? So Cu is going to go with what of water? H or OH?
OH.
So, and it took 2 NO3, so it's going to take 2 OHs. Put parentheses around the OH. There you go. And what else is going to be made?
Just nitrogen.
H, NO3, right? You're going to put H with the back part.
H, NO3.
Right. No, you don't have to put parentheses if you just need one. Then you're going to go back in your notes here. Right here. There's your strong acids. There's your strong bases. Are any of those strong acids or strong bases? Coming around.
be a strong base?
Okay, so this would just be K, and it would go with OH, right? And this would be H2PO4 with a minus.
Okay. So this would be KOH.
Mm-hmm. Okay, so if you look at, and no positive or negative. So if you look back a few pages where we had the bullseye, right above the bullseye, we went through what are my strong acids and what are my strong bases. So then we look and say, are these strong acids or strong bases? Okay, which? Okay, split it. The Li is the positive, right? So it's going to go with the OH minus of water. So you get LiOH, right?
Mm-hmm. So you combine those two together. And the Cl is minus, which goes with the H minus or something?
H plus,
H plus.
right? So
Oh,
you,
because opposite. So
you're just splitting water.
HCl.
And LiOH.
LiOH.
Then you go back to where your bullseye was. And those are your strong acids, those are your strong bases, and you determine which one you have. Do you have any of the strong acids or strong bases?
And if we don't, then we just write none.
No. It's either a strong acid or a strong base. So if
Oh,
it's
they,
not there,
they will be.
one will be a strong acid or strong base. She won't give you 2 weeks.
So is that right?
This one's weak. That one's not one
That's
on your
what I'm
list.
saying. Because, so if it's not on our list,
It's weak.
okay.
And then because this is a strong base with a weak acid, it's going to be a pH bigger than 7, and it'll be a base. Yep, so this will go with OH.
Oh,
So CaOH2, and this will go with H, so H2Cl3.
so when we read that,
So Li plus would be with the OH.
Right, but that's not weak.
It isn't. Let's see it.
that's kind of dope.
So if you look back here,
What you're gonna do?
LiOH is a strong acid, or strong base.
So just be neutral.
So strong base, strong acid, neutral, yeah.
But if it was weak, strong, and
It would be strong acid, yeah. It would be, yeah. Okay, I'm going to go here and then come back.
And then look at, so basically you're just supposed to split it apart.
Right? And this would go with the OH, and so it's not there, right? Or- Yeah, it's not there. And this would go with the acid, and it's not there. So you got the hard one. Because Mg is really right above the tetras pattern,
Yeah.
and so it's a stronger base, but it's not the strong base. So this actually is slightly basidic. So it's just above 7.
So it's basic.
Yep. It's basic, basically. Ha ha ha. Okay, guys, let's work on these. Come on.
Yeah, so I have, so like it just says identify the cation and anion. So what are we supposed to find?
Cation is Cu, anion is NO3, and then
so
you're
like
trying
on
to.
this one, so I have Li is the cation, this is the anion,
Right.
and then we
I'm not
find
coming
out
back
that it
up
goes
to write
with LiOH, so LiOH, and HCl,
And then identify.
strong base, strong acid, and then pH of 7. That's all we
Right.
like.
Yep.
That's,
And this would be neutral. That's salt.
So,
KOH, HNO3. Yep. This is a strong base. KOH is part of our tetras.
but otherwise I
Let me see what the acid is.
got
HNO3 is also a strong acid, so strong base, strong acid is going to be neutral at pH 7.
So, is this how I would do this one?
This would be OH2, right?
Yeah.
And then you'd have a strong base, weak acid. You don't have to worry about this side. You're just
So-
going to tell it what it is. Strong base, weak acid. So it'll be pH greater than 7, which is a base. Okay? Yes, ma'am.
Okay, so what I leave as CL or HCl?
HCl.
So then it'd be strong acid, or strong base, strong acid.
pH of 7, neutral.
How exactly would I write that? Because if it's if that
So you'd write MgOH2 in parentheses. And you just put underneath it stronger base. It's really not a strong base, but we'll talk about it.
stronger than the other one, it's,
Yeah.
it's stronger but not as
And then HC2H3O2, and that's weak acid.
HC. So would this be a strong base and that'd be a weak acid?
Yep. So overall, it would be basidic, pH above 7.
Alright, so it's HC3H2O. No, no.
This right here. Just put that electrode. Okay, let's see what we can do. We are running a little bit slow here. I'm sorry, I don't know where my other thing went. I don't think you could. See if I can write with my finger. Sorry. It's all good. Sorry to make it, trying to make it through without bugging anybody.
So what is something like CU, which is in the middle, and then NO3? Is NO3 on the back of the periodic table?
Yes.
So we can see what charge it is, because that one will have to.
+2. It's a +2.
Okay. Yeah, I just didn't know exactly how to find it, because is the NO3?
NO3 is -1.
Oh, and then there's time, so it's fine.
Okay, well, just a second. Will one of you touch with your finger this right here? And touch a color? Do one of these buttons on the bottom because they'll make it skinnier. Okay. Now, you should be able to use your finger to write, too. I'm just going to check and see. Yep. Okay. Run fast. What? Yep. My board's off a little bit. Okay, so let's start going through these. You will need to be able to identify if a salt is going to be, frets are falling out. If salt is going to be an acid, base, or neutral, and you'll need to be able to tell me what the pH is. So on the first one, you've got the pH of 7. So is it acid, base, or neutral? Neutral, right? And it went away. All right, so this is neutral. This one right here, they did split it correctly. Okay, we've got a weak base and we've got a strong acid, so it's going to be below 7, and it's going to be acidic. Bottom one here, strong base, weak acid, and it's going to be basic. Very good. On this one, split, strong base, weak acid, it's going to be above 7. Okay? All right, number E. We got magnesium hydroxide, other than we didn't do magnesium hydroxide correctly. And this right here should be HC2NO3. It is a strong base, it is a weak acid, it's going to be basic. Here, splitting KOH, NO3, we've got a strong base, strong acid. It's 7, and it will be neutral. So you should be able to identify these very quickly. If you know your strong acids and strong bases, hint, hint, if you don't know them, get them on a card. Okay, you will need them. All right, going forward. Now we need to be able to say how we're going to be able to make these salts. So I am trying to make calcium chloride. I need to use the information that we did before to be able to figure out how I'm going to make it. We need to state what acid we are going to use and what, and they gave us the end of it, we're going to use. So what acid would you use to do this? HCl. How did you get that? The anion, right? The anion came from the acid. So HCl plus, we need an oxide to go with that will help us make that salt. So what oxide would go with that? Ca, right? Oh, yeah, that's supposed to be Cu. Cu and O. Copper likes to take a +2. It will take a +1 if it's forced. It's not forced. Is this a balanced equation? No, it doesn't matter. What they wanted us to do was just tell us what we can put together to make that salt. Okay, let's look at the next one. They told me what they wanted. Okay, so on this next one, we got magnesium sulfate. What acid am I going to put with it? H2SO4, yep. Sulfuric acid. Plus, what carbonate am I going to use? MgCO3, right? It is not balanced, but I can write down how it's going to be made. If I were to finish this one, what would be the products? What else? What other products am I missing? An acid and a carbonate give me what? It'll give me water and what else? Carbon dioxide. Okay, what about the oxide? What am I going to get with the oxide? This plus just water. Good. So you should be able to finish it, and they're not balanced, but we could go back and balance them. Okay, I'm going to make lithium bromide. LiBr. What is my acid? HBr, hydrobromic acid. Good. Plus, what is my hydroxide that's going to go with that? LiOH. What am I making besides LiBr? Water. Okay, and you could go back and balance them. We're not going to take time to go back and balance them. You need to be able to do this. You need to be able to do this. Okay? All right, going forward. This is sort of a summary sheet. Okay, it is in your notes. It's a summary sheet of everything we talked about. If I put a salt in water, it will separate to its ions. When it separates to its ions, it's attracted to a water. And the water will split and either give up its hydrogen or give up its hydroxide, depending on if it's with a positive or negative. If this Ka and Kb are equal to each other, then we get the pH of 7. If we have a higher Ka, or stronger acid than base, then we're going to be acidic. If we have a stronger base than acid, then it's going to be basic. That's what that's all about. You need to know your strong acids and bases. Okay? You need to know your strong acids and bases. Backwards and forwards. Life will be a lot easier. You need to be able to write a Ka or a Kb for different compounds. Basically, all that is the products over the reactants. You also take it to the coefficient. So if this had a coefficient of x, I would go HA to the x power. Okay, we're going to write Ka's here in just a minute. Yep. Now, if a Ka is less than 1, and almost every Ka is less than 1, then we're going to have a pH between 2 and 7. If it is equal to 1 or bigger, we're going to have a pH that's even lower than 2. We're just getting definitions down. Base is basically the same thing. It's always products over reactants. Do you notice one thing that's missing in the Ka and Kb? What's missing that's in the equation that's not in the Ka or Kb? Water. Water is not in there because it's a liquid. If it's a liquid or a solid, it is not included in the Ka or Kb. So, no liquids or solids, okay, are included in a Ka or Kb. Put them in parentheses. All right, going forward, we have a chart, and they will either give you a chart or they'll give you a few of them on a chart. You need to be able to look at the chart and be able to say which is stronger than another. Now, if they gave you sulfuric acid and they gave you propanoic acid, which one's stronger? Sulfurous acid. You can also look at the exponents. The smaller the exponent, the bigger the acid, the strong, as far as strength. The closer I get in the exponents to 14, the smaller the amount I have of acid. Same thing with base. If I were to take and say, okay, let's compare the fluoride ion with the hydrogen phosphide ion. I would look and say, okay, this one has a negative 11 and this has a negative 7 Kb. So my hydrogen phosphate ion is a stronger base than my fluoride ion. How many heard in the news about Logan having problems with copper in their water because of a fluoride? Okay, adding fluoride to our system, into our water systems, if it's not monitored very carefully, can cause copper and heavy metals to come into the water. Yes.
Is that in like the newspaper? Like
It was in the news this morning. High copper ladders.
like local like
KSL. Okay. All right. So you have this on your chart. Yes. This is general. So as I'm increasing in strength of acid, I'm going from something like 10 to the minus 14 up to 10 to the minus 1. You might want to add these things in. pH is going from 14 down to 0, or actually below. It actually can go negative. To about a negative 2 is the strongest I've seen a pH. That is a very, very strong acid. If I've got a base, okay, pH will increase. And it can actually get up to about a 15.5 is the highest base I've seen. Yes?
where have you seen those at?
I can make them.
You can make really, really, really big. You just mix a bunch of stuff and
No, not mixing us. It comes strong. I get it, and I dilute it for you, so it's not as hazardous.
so you just buy it though.
Yeah, I just buy it. Okay, so and the base concentration for H3O decreases. Okay, so you've got to be able to look at this and be able to look and say, this is a strong acid, this is a strong base, this is not a strong acid, this is not a strong base. And you need to be able to relate the Kb, Ka, and that. Another way you can look at it is Kw is equal to Ka times Kb. So if I want to find the Kb or the Ka and I have the opposite, Kw is always 10 to the minus 14. Okay, going forward, here is an example problem. You are given these 4 Kas. You're asked to arrange the acids in order. Be very, very careful. This is my big, 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 big. She will change this. On one problem, she'll say decreasing. On another problem, she'll say increasing. Make sure you look at that. She won't do what I did in little parentheses and say strongest to weakest. She will just say decreasing acid strength or increasing acid strength. So what am I looking for? What's going to be strongest? Because I'm going strongest to weakest. C. Okay? Because you're looking at the lowest number here, right? So C. Then what? B. That's pretty easy. Then what? D or A? I heard both. D or A? Be D. And then A. Okay, now look at the next one. Because she could give you a set of data and ask several questions on it. So arrange the conjugate bases. Conjugate bases. So if I have a strong acid, the conjugate base is weak. If I have a weak base, the conjugate acid is strong. So I'm just going to flip that whole thing around, right? So I'm going to go AD, BC.
So I have a question on the other side when you were talking about acids.
Uh-huh.
The more acidic it is,
Mm-hmm.
like the lower the pH, the higher the.
No, it should be, we go back. So the lower the pH, this is a stronger acid, this is a stronger acid.
Yeah, so if it's like really acidic, the exponent would be bigger.
Littler.
Oh, it's negative.
Okay? All right. So we're going to go through here. We're going to write the Ka expressions now. So we got hydrofluoric acid. HF, right? Hydrofluoric. We need to be able to write down acids by their names and know the compound. Here's a hint. If you don't know your polyatomics, the ones we've been using a lot, I would put them on my card because you're going to need them to know how to write them. You are going to, well, I should probably do it this way. You're going to add it to water. So this is AQ. We're going to make it AQ. We're going to make that liquid. And we're going to form what? Bronsted-Lowry. What is the acid going to do? Donate to protons. So it's going to become F minus, AQ. And water is going to become what? H3O plus. Good. AQ. Now, to make the Ka for this, I'm going to take products over reactants. I am not going to include the water. Water is not included. So I'm going to take products, concentration of F minus. All right. Try that again. Concentration F minus, AQ, times the concentration of hydronium ion, AQ, since they're all ones, I don't need to worry about exponents, divided by the concentration of F, HF, AQ. Okay? Usually when we do the Ka, we drop the AQ because the concentration boxes mean molarity. So let's do the next one. Hydrogen sulfite ion, HSO3 minus, AQ, plus water is going to give me what? How do I know it's with water? Right, the dissociation reaction for the expression of the following weak acid. So in order to dissociate it, I'm going to have to put it in water. Okay, what else? What am I going to get? I'm going to get what? SO3, 2 minus, AQ, plus what? H3O plus. Good. AQ. Okay, so what's my Ka going to look like? What am I not going to include? Do not include water, solids or liquids. My products are what? SO3, 2 minus, good. And H3O plus. Divided by what? HSO3. Okay, really quickly, do the bottom one. Who can tell me what the acid is? You've got to be able to name these and write them. Hypo means what? Less oxygen, right? By 2. So what does OS come from? Phyte. So chlorite. What's chlorite? HClO. It's got to have an oxygen if it's ite or ate in the ending. Okay? I'll give you this much. Write the rest. "30-second head start, and then I'm writing. Bronsted and Lowry had a theory which they came up with independently. Okay? All right, now you got to hear me crone. Are we okay to go forward? Did everybody get that bottom one all right? Yes, I got it. No, I didn't. I am so confused. Okay.
I'm being really confused in the middle.
Well, hopefully you'll catch up to us. Okay, here's another type of question that she likes to give. Look at these pHs. Now notice, arrange these acids from the weakest to the strongest. So what's the pH of the weakest one? So that's C. Good. Okay, then what? Okay, the negative usually throws kids. Don't let it throw you. Just put it in the order it would be. Okay? Good. Be careful. Be careful. This sounds really simple, and I know it, I'm just harping and beating a dead dog, but I know. Horse is less graphic. Okay, I'm beating a dead stick. Whatever. Okay, now, I want you to do this again. Now, she's going to give it to you like this, not like I did at first. These are salts. You need to figure out, are they going to be acid, basic, or neutral? And where's the pH going to be? Okay, go ahead and do it. I'm going to pull you guys up that haven't had a chance. So, Jacob, number 1. Jacob. Aspen, number 2. Caleb Brown, number 3. CV. Kayla, number 4. Jace, number 5. And Caleb Smullen, number 6. As fast as you can get yours up, get it up. So we're not waiting very long. The rest of you do all of them. Uh-huh. Yeah. Yep, that is. You just have it in word form, so you have to do figure out what it is.
Oh, I don't get it.
You have to write the formula for it.
So this, I just break it down, but how do I know if it's OH?
So the first one is always going to go with the OH. So the sodium here would go with the OH, so it'd be sodium hydroxide.
I'm 2, right?
I don't remember.
As
Oh, what is sodium?
Na.
Na. You just did sulfur. Okay, nitrate is going to go with hydrogen.
Wait, NO3.
NO3, but it's going to go with hydrogen. So where's the hydrogen go? Yep. Now you look and see. Strong acid, strong base, yes or no? What pH going to be? So write the formula of the salt too, please.
Okay, so potassium is K plus and borate.
BO3 3 minus.
Where did you
3
come
minus.
Okay,
I just know it. I don't know if it's on your thing or not.
should we-
Nope, it's not on there.
Okay, so, and then another question, it was just back earlier. So, right here, keep the coefficients. So if the coefficient is bigger, or like lesser, but like just forget a minus, if it's like a higher number, then it would be a lower pH, right?
No. It would be a higher pH. So it's sort of backwards. So this means I have very, very little. I have 0.0, 14 zeros, and a 1. This means I have
So this would be
0.1.
stronger.
Yes. So when we take the log of it, the lower number, the 0.1,
So
becomes
then
1.
should I switch those? Because as,
No, as it increases, as the concentration increases, which is happening here. So as the Ka increases, it becomes stronger. As the pH gets lower or decreases, it becomes stronger. So this is what happens with acid strength.
I thought these two were related to each
They
other.
are sort of, but not. This is the negative log of this.
Okay, so they're inverses.
Yeah. So potassium sulfate, so you've got strong and weak, so it's going to be what? What we did last time is right here, but you didn't write it down.
That's why I was confused
Yeah.
because I was in here.
So, no, that was earlier today.
Yeah, I was at my car.
Okay, so if I've got a strong and a weak, then the strong overrules. So I'm going to have a base solution which is pH greater than 7. Okay, those of you that haven't got yours up, get them up, get them up, get them up, up, up. Okay,
I couldn't think of it anymore.
Okay. So are these the words? Okay. So we need to pull those out of our white ones and put them onto scratch paper. And then what he did last time that was sort of helpful is as you're pulling it out, and unlike you want to do candy, he wrote the word right here in the center. So you'd write candy with the periodic table letters, and then write whatever it was that he was trying to spell right here in the center. So the rest of us, when we cut it out, knew that that was a word. Does that make you?
So I write it like capital C's and lowercase a, then I put out like what family?
Yeah. So just like these should still be organized, hopefully, except for this top bunch. So like this, he did this, but then he wrote the word here. So if this was Patrick, he would write Patrick here. And then we go copy it and pull it off. Do you see what I'm saying? So when it comes through the copy machine, we know what we were trying to do. Does that make sense?
Yep.
And you can take these off and put them on differently. Okay? And here's some extra scratch paper. Hopefully we should have 3 or 4 of each element. You might want to get a different tape dispenser. Mine sucks. There's 2 more back at the back.
Sorry.
Nope, you're good. So this helps me to know if you're getting it right or you're not understanding. So, doesn't want to stay on. Put it down 3 times today. Okay, here we go. Let's go through these really quickly, guys. Everybody up front, we need to move. So sodium nitrate goes sodium hydroxide, nitric acid, both strong, pH is 7. Great, it is neutral. Don't forget that. Sodium nitrate, big sodium hydroxide and nitric acid, strong base, strong. I got that up there. Nitrite. Be careful. Nitrite is NO2. It's not a strong acid, it's a weak acid. That makes this not 7, but a pH greater than 7, it's going to be base. Okay? Potassium borate, potassium hydroxide, and boric acid, which they used to use for cankers. It is a strong base and a weak acid, so it is going to be basic, greater than 7. Potassium hydroxide, sodium sulfite, and it is a weak and a strong, and so we are going to be above 7, and it's going to be base. Lithium hydroxide, nitrous acid, strong for the base, weak for the acid, and since that it's going to be a pH of above 7, which is basic. Sodium hydroxide and carbonic acid, we've got a strong base and a weak acid. We need to be bigger than 7, and it is basic. Okay, so we just had a little few things that we needed to fix. You need to be able to do this backwards and forwards and know how to do it. Okay, so let's talk about buffers. Buffers are B4 that we've been doing back in lab. That's what we've been doing in B4. A lot of you are still struggling with B4. Next time when we come, we need to make sure we had Part D and B4 done before we leave and everything cleaned up. Buffers are solutions that resist change. They're made out of a weak acid and it's salt or a weak base and it's salt. A buffer capacity is how much acid or base can I add to that buffer before it breaks. And when a buffer breaks, that means it doesn't maintain its same pH. It goes really high or really low. Okay, so that's a buffer capacity. How much can that buffer take before that buffer does break? And when it breaks, the pH changes drastically. Just like in our titration curve. So it would go along steady, 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 and then it peaks up. Or it could go along steady high and peak down. Okay? So, going forward, buffer is a solution where the pH it changes very little. So we have very little change in pH. Most buffers are composed roughly of about the same amount of each. However, if we know we want to buffer something and we're going to continually add acid to it, then I'm going to make sure the salt part of that is stronger than the other part. The buffer resists change, pH change, because as acid or base is added, it reacts with the weak acid. As acid is added, it reacts with the conjugate base. And that the conjugate base is the salt. Okay? So this is what a non-buffered solution would look like. Here I have water. And if I add to it, going on the top, to this one in the middle, acid, it's going to force the pH down. It'll go down. There's nothing in there to stop it. If I add base, like I do on the third one out here, it would go high. Now, if I take a buffer solution and I make a buffer and I want it to be a specific pH, I've got to look at the pH, the Kas of the buffer solutions I want to use. I've got to look at the Ka in order to determine what pH I can keep it at. But if I take that same amount of acid and add it to a buffer solution, notice that it only changed just a 0.04, where before it jumped 5.3. If I do the same thing with adding a base, it only jumps 0.03. Okay, so it maintains basically that pH. We have in our system many buffers, and it's very important. Here's what an acid does. If I add more acid, that acid reacts with the base, and I go back towards the weak acid of the buffer. So that strong acid that was in there isn't there anymore. That shift does not increase this part of the Ka very much. So we end up with a little bit of change, but not a lot. This is in your notes, so if you're not putting it down, you're missing stuff. Yes?
It's just like a weak base with salts or a weak acid.
As salt. Mm-hmm.
But it's not like a weak base with a weak acid.
No. Now, they call the salt, if you have an acid and it's salt, that's actually the base of that salt. So yes, you do, sort of. But they usually don't use that verbiage on it. Okay, the same thing's going to happen with a base, but we're going to be adding OH instead of H3O+. We okay to go forward? Jace, you with me? Okay. Just off into space a little bit. Base is going to be the same thing, but with the base, it's going to react with the acid. And so the weak acid in the buffer. And it drives it forward so that we get a weak base instead of a strong base. And that strong base is sort of mitigated, and we only get a small change. The ratio doesn't change much. The H3O doesn't change much because of that. Because it's not reacting with the water. It's reacting with the weak acid or the weak base. It says the same thing. Okay, we're going to buff forward. So you can see a buffer has an acid and a conjugate base, like you were saying, Caleb. It will have a conjugate base, but instead of having the minus here, we'll have a sodium or potassium or something with it. Okay, and we have a Ka. Which of these three buffers is the strongest? Acetic acid, yeah. Now, we have several systems, buffer systems in our body, intercellular and extracellular. One of our most important one is the carbonic buffer system. So if we look at the carbonic buffer system here just for a minute, in normal conditions we go backwards and forwards from having the ions to having the carbonic acid to having water and carbon dioxide. But if we have too much acid in our system, our body shifts it and we give off more carbon dioxide. If we don't have enough acid in our system, it takes the carbon dioxide we are producing and forces it backwards to the ions, to the positive and negative ions that we need to go across cell walls. Okay? So, when we do a Ka, here's a general Ka for weak acid. It does depend on that concentration. If we're trying to find out what the pH is for that concentration, we solve for the H3O plus ion, and then we'll take minus the log of that to find the pH. The hydronium ion does determine the pH on a buffer.
Are we supposed to write all this?
Write down what you would like. We're going to get an equation that will give us a little bit more in the next couple pages. So I'm going to go forward. Everybody okay? You can come back and look at it if you need to. Okay, so when we focus on the human body, normal blood needs to be between 7.35 and 7.45. The principal buffer in the blood is that carbonic acid buffer that we're talking about, carbonic and bicarbonate. So this is what's happening in the blood. CO2 is constantly being produced by a metabolic process in our body, and the amount of CO2 in our body relates to the pH in the blood. If we aren't able to keep that under control, some things happen that are not good. So first, we could get respiratory acidosis. A lot of times after you come out of surgery, they'll say, breathe deeply. You need to take a deep breath. Because most people, when they come out of surgery, are just really short breaths. And if you're really short breaths, you're not expelling what you need to expel. So, it also, respiratory acidosis also happens when people have, my brain just left, pneumonia. Bronchitis can also cause it because people don't want to take a deep breath. It hurts. So they don't take enough oxygen in. And because they don't take enough oxygen in, they're not getting rid of the CO2. They increase the CO2 and it forces that this way, which increases the acid in our blood. And acid in our blood can cause a lot of problems. We could also get respiratory alkalosis, which is making our blood basic. Okay, so in this is when people get very excited and they hyperventilate and just they're taking too much air in. And when they take too much air in, we're expelling too much of the CO2 and causing the reaction to go backwards, and we're losing the ions in our blood. And when we lose the ions in our blood becomes more basic. And that can cause problems too. So that's when the people hand them a paper bag and say, breathe into paper bag, because they're breathing back in their CO2 and bringing back their blood level. Okay, so we want that blood level, pH, just to remain constant. So we're going to be using what's called the Henderson-Hasselbalch equation. We used it in lab already. Henderson-Hasselbalch is pH is equal to pKa plus the log of the conjugate base over the conjugate acid. It is a form of what we had on the other page. We just took the negative log of everything that we had on the other page. Remember that the pKa is the negative log of Ka. We're going to be doing some equations with that in just a second. It is the Henderson-Hasselbalch. Very nice and easy that he figured that out because it makes life a lot easier to figure out the pH of stuff. So here is an equation. We're going to use Henderson-Hasselbalch. Plug in. Find me what the answer is. I'm going to go slow and write it slow. I want you to see if you can beat me. I will write the Henderson-Hasselbalch equation right here in case you forgot. Okay, how do we do?
I am so lost in where you got
Where I got what?
the 1.7. Wait. Oh, so that's not on that page. Yeah.
Yeah, it will be 4.1 because I only have 2 sig figs. Thank you. The nice thing here is if you look at the Ka, the final pH should be close to the exponent on it. So I just gave you the Ka. On these others that are coming up, I put the Ka up here. I realized I didn't put it in your thing. Okay, are we ready for the next one? Okay, so answer, pH there. Next, you're going. K's up there for you, so you don't have to find it, but you could research it. I'll give you a second head start. Just a second. Maybe 2. Tiani, I'm going to take that phone away and throw it.
But I just do it already.
Okay. Base. Always base. Nope, that's not right. Oh, because I had the other answer in there. So when I said that's not right, I looked right at the Ka and I looked at my answer and I realized that they weren't anywhere close to each other. So that's a good check, okay, on this. Because if you know that you're supposed to be close to it and you're not, then take the time to put it through one more time, because if you're not close to it, much better. So 1.8. Okay, so notice that it is close to that too. The first answer I got was 5 point something. I went, no. And I realized I'd taken the other answer and added them together.
You're supposed to be close to the Ka.
The exponent on the Ka. Okay, so here you go, one last one. This one's a little bit different. Careful, I gave you the pH this time, and I gave you the Ka. I want the ratio. I want you to solve for the ratio. So that should be my ratio. Okay, so as I'm setting up back in lab, it depends on how much I'm making, but the ratio always needs to be 4.4 of the base to 1 of the acid. Okay? All right, we're going to move ahead forward here really quickly because we're running out of time. 4.4. Okay, I want you to really quickly just put the KAs down for this in your notes so you can practice a couple of them. I looked up the KAs for you that are not on your notes. Put them down real fast, and then we're just going to buff through this really fast so of the time. Take a chance. Try these on your own, but you'll need the KAs.
We can have anyone like that last one on the test because I don't know if we have you back on this one.
We can go back over it, but let me get where we need to be today and go back. Okay, going forward. Learning check. Let's see if you can do this really fast. Can you figure out what the concentration of the unknown acid is? Can you tell me what an amphoteric substance is? And can you tell me what makes up a buffer? So what are we going to use on the first one? Okay, quickly, throw it through. Tell me what the answer is. And I'm watching the clock. We get out a little bit later, though, right? Because it's late start. Okay, so I can slow down again. I'll go back at the end of this, Caleb, and go over that problem again. Just remind me. Then tell me what 2 amphoteric substances could be. And then tell me what makes up a buffer. I'll give you a minute more. Okay, here's some answers for you. How did you do? So, volume, it should have been M1, not V1. Here, that's my mistake. Okay, the molarity is 0.17. The 2 amphoteric substances, there's a lot you could choose from. Water is a very common one to know, but anything that has a hydrogen, that can get rid of a hydrogen, and that can gain a hydrogen, that's the key here. To be amphoteric, you need to be able to lose or gain a hydrogen. And then what makes up a buffer? A weak acid or base, and it's salt. Okay, we've got just a few more things to go through. And they basically have to do with the environment and our bodies. So carbon dioxide in the oceans, why do you think it's a concern? It doesn't really kill the fish or the plant life, but it has to do with this down here. Coral, it actually kills the coral reefs and actually eats it. So it eats the coral reef. It eats the coral and because it's an acid, and the coral is made out of calcium carbonate. It dissolves them. So they lose the coral reef. Okay, so let's go on to the next one here. Acid in your stomach is good, but acid in your esophagus is bad. You can actually get what's called Barrett's disease. There's a sphincter right here, and if the acid comes back up in, it causes sores, and the sores get so scar-like that it causes the sphincter so it doesn't close. And so the stomach acid is always coming up. Yeah. So they have to go in and make a new sphincter. You actually have a little muscle here that's the sphincter that holds it closed. Okay? If you end up with an ulcer is a hole in the stomach, and the stomach lining is built so that it can hold that acid. If that acid gets outside the stomach lining, you actually start eating yourself away from the inside out. If you have an ulcer down in the duodenum, this is where, in the duodenum is where your gallbladder now puts in base to start neutralizing that acid as it goes through your small intestines. if you have an ulcer here, you have a second problem, because in the duodenum you also have the acid, but you also have the base going in right there. So depending on where that ulcer is could be a problem. They have special diet tips for those that have ulcers, and that is to use foods that prevent it. So you get rid of all your buttery pastries, your bacon, your French fries, your red meat, your alcohol, the milk, mayonnaise, anything that is fatty. And you go to avocados, raw honey, kale, cabbage, spinach, Brussels sprouts, celery. Yeah, they actually make a mayonnaise-like thing with the avocado. So it's good. It's like guacamole, but you can't have the mayonnaise in it. Okay, so what we've learned today, we've gone over on the board. You should be able to take a salt, any salt, and be able to tell me if it's acid, base, or neutral. You should be able to tell me some of the uses. What are some of the uses of some of the salts? To make buffers. Okay, you should be able to tell me what a buffer is. A weak acid or a base that is made so that it's with its salt, so it buffers or prevents change in pH. You should be able to tell me what a Ka or Kb is. Equal concentrated for an acid and the others for the base. And be able to look at a list and tell me which one's stronger, which one's weaker. Okay, so we wanted to go back really quickly. We'll go back to that problem that you were all concerned about. Right here. Okay, so Caleb, where did you lose me on this one? So these, up to this point, I think most people followed me to here. Then I took the power of 10 on both sides because I had a log I needed to get rid of. So if you take to the power of 10, whatever's left, then the log and the power of the 10 cancel. So 10 to the 0.64 I took over, and this becomes by itself. So I just brought that over here. And then I just put that in my calculator. That's what I got. That's the ratio I have to have. Basically, that's saying for every 4.1 or 4.4, I get one of those, one acid. Yep. Okay, so one more time, what's going on for the rest of the term? Next time, you need to be prepared to titrate a beverage. It needs to be a pop or a juice. It has to be a little acidic. You're going to want to do at least 2 quick drip titrations to make sure that your whatever pop you brought is not too acidic and you run out of stuff. If you run out of stuff and it hasn't changed, then you need to try it again with less acid. So it's going to be a trial error kind of thing. You might start with 10 milliliters and you might end up putting in 1 at the very end. Okay, depends on what acid or base or what beverage you choose. Do the quick titrations first because you can do it really fast and right when it turns stop, and you'll stop and see about where you need to slow down for your pH one, where you use the pH probe. Yes?
So back to this, I see where you got everything, but where do you get the 10 from?
Right here?
Yeah.
So to get rid of this log right here, I had to take both sides to the power of 10.
Power of 10.
Yep, to get rid of the log. Okay, also, so lab next time, you got to work through D and B4. Please, how many have made it all the way through B4? 1, 2, 3 groups. Okay, you've got to make it through B4. Okay, so 4, we only have 1, 2 groups that haven't made it through. Good. Tutorial, you'll be open during tutorial. So if you haven't finished B4, I would probably do that so that on Thursday when you come, you can just concentrate on your beverage titration. Do not forget your beverage. Okay, a pop or a juice. And you need about 30 milliliters. Monday, keep sitting down, you're okay. Monday is your day to clean your crap up and get things in. Okay, finish your lab, get it turned in. Do your homework, do your Learn Smarts, do whatever you need to do. Remind me though. I'm going to need your reminder to give you your review on Thursday so that you have it. Did you notice at the end of this packet there is a review, a pretest that you can go through and try? Okay, make sure you go through and try it. Anything that has to do, oh, I forgot to tell this class. Anything that has to do with equivalence, though, I skipped that part in the notes because it's not on the test. So don't worry about it. Okay, anything on the pretest that has to do with equivalence, I didn't take it out, so just ignore it. Wednesday, tutorial. Yours to ask questions. Wednesday, in class, yours to ask questions. Friday, test day. If anybody has to take the test early, Wednesday after school.
So Wednesday is our early, and then Wednesday in class, is that the free day?
Wednesday in class will also be basically a free day, but I'll be concentrating on any questions you have, any help that you need. Okay? All right, any other questions? Okay, then that's the end of term. So please remember that you can turn in any labs from before. Get them in. Any homeworks before that you haven't done. Any Learn Smarts before you haven't done. What was the thing I told you about the end of fourth term's grade? If you get a better grade then, I'll go back and change it, but you got to tell me. I'm not going to search back and say, oh, did they get a better grade fourth term than they did the rest? You need to say, I got a better grade. Can you go back and change it? And I will. Okay? We will know our final grades in this class by the week before the end of school, because I have to have my grades in then. Okay? You have a week and we'll do some fun stuff. And you'll help me move classrooms because I'll be moving to Bagley's.
Where's Bagley?
Bagley's moving to Hershey, Pennsylvania.
She's moving? Like, wow.
Yeah, moving.
Why is that?
Her husband got a job in Hershey, Pennsylvania for twice what he's making here, so. Huh? Thanks. No. My family's here. My family's here. I wouldn't leave my grandbabies. Come on. Huh? I can visit her. They make Hershey candy. There. Okay, so we'll be doing that, moving me to the other room the last week. So fourth term. I'm going to take over biotech. So if any of you are juniors and going on, biotech is actually the next thing.
Well, I took that class before this one. I messed up. That last year.
I wish I could still offer 1120. 1120 is biochemistry, and biotech is the application of biochemistry.
Jay, do that.
I'm going to teach CE Chem also. So I'll have CE Chem and biotech.
That class is fun.
Yeah, there's a lot of fun stuff in that. I'm excited to do the gels, the PCR and gels. So how many juniors do I have in this class anyway? Juniors, raise your hand. Hi. I want to see you in biotech next year. Okay, we'll be doing gels and all kinds of cool stuff. Right now, nobody. So medical forensics, we're still trying to find a teacher. They wanted me to do that too, and I just was like, I can only do one new thing. So.
Just do everything and biotech. Just do everything. How you got? Go big or go home.
Go big or go home.
Are you just getting a raise?
You're funny. I'm getting my own lab. That's sort of like a raise,
That
right?
was so nice having our own lab. Yeah, a little bit. Yeah. We had all the fancy stuff too.
Yep. Biotech, the equipment they use is $250,000.
So that's where all our access comes.
Nope, she wrote grants to it for it.
Yeah, Bagley.
Bagley wrote grants like crazy. She's crazy nuts when it came to writing grants.
All right. We should write grants for my bank.
For your what?
My bank.
Your bank account?
$250,000.
Yeah, good luck with that. Have a good day, guys. Be ready for lab next time.